In this video, we're going to go over the angle-side-angle postulate and the angle-angle-side congruence theorem. The angle-side-angle postulate, ASA for short, is our 19th postulate, and it says that if two angles in the included side of a triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. This is very similar to the last postulate we went over, side-angle-side. Side-angle-side dealt with an included angle, and that included angle had to be between two sides. For this postulate, the angle-side-angle, the included side is between the two angles. Let's take a look at this. So I'm saying if angle A is congruent to angle D, and angle B is congruent to angle E, in the included side, meaning the side between the two angles, in that case it would be side AB and side DE. If those sides are congruent, then the triangles are congruent. And that is the angle-side-angle postulate. If you get confused about what is the included part, think included meaning between. Now let's go over the angle-angle-side congruence theorem. The angle-angle-side congruence theorem is a little bit different than the postulates we've been going over because the postulates didn't need to be proven true, whereas this theorem does. So T20 says, or AAS theorem for short, if two angles and a non-included side of one triangle are congruent to the corresponding two angles inside of the second triangle, then the triangles are congruent. Let's go ahead and look at a picture and then prove this theorem. So based on this theorem, we're going to start out with two angles that are congruent to two other angles and a non-included side, so a side not between those two angles that is also congruent. So we have angle B congruent to angle E, angle A congruent to angle D, and segment BC congruent to segment EF. And that is given in this theorem. Now we need to prove that these two triangles are congruent. So let's go ahead and do a two-column proof. So first off, we have our given. Angle A is congruent to angle D, angle B is congruent to angle E, and BC, the segment, is congruent to the segment EF. Now let's think of a postulate we can use to prove this theorem. We just went over the angle-side-angle postulate. So if there was a way to calculate this other angle, we could use angle side angle to say that the two triangles are congruent. If we already know two angles within a triangle, we know that the last angle would be congruent to the last angle of another triangle. And that's by the third angle theorem. So now we have angle, side, angle, angle, side, angle, where the angles are congruent and the included side is congruent, so we can use the angle, side, angle postulate to say that the two triangles are congruent. Therefore, triangle ABC is congruent to triangle DEF. And that is what we needed to prove. That if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. Angle, angle, side congruence theorem. So to help us with proving that two triangles are congruent, we have the side, side, side postulate, the side, angle, side postulate, angle, side, angle postulate, and angle, angle, side theorem. In the first, we need to know that the three sides of one triangle are congruent to the three sides of another. In this, we have to know that two sides and an included angle are congruent to two sides and an included angle of a second triangle. For the ASA that we went over earlier in this video, we need to know that two angles and an included side are congruent to two angles and an included side of another triangle. And the AAS, angle, angle, side theorem, we just proved if two angles and a non-included side are congruent to the corresponding two angles and side, then the two triangles are congruent. And those are 4 ways that we can use to prove that two triangles are congruent.